Hi friends, welcome back to your channel. In this channel, we try to solve the previous year's physics question papers for NEET undergraduate exams. This is also helpful for JEE mains. This is solved in a very student-friendly manner so that you can understand and apply the concepts. We have included all types of questions appeared in the exams so that your preparation is complete. If you like the content, then we urge you to like the videos. This motivates us to create more content for you and help you in your exam preparation. We also urge you to subscribe to the channel so that you are immediately informed of any content added to the channel. If you have any doubts, then please feel free to add in the comment section. We will revert to you at the earliest possible. So without much ado, we'll go ahead and try to solve the questions which we had shared earlier. So this is question number 1. So in this question, before you go to the question, I think it might be helpful to go through some concepts. So in the concepts you can see, so this is about linear motion and this is about rotational motion. So the equivalent formula in case of linear motion we had S is equal to ut plus half at square, or the S is equal to distance, u is the initial velocity, t is time, and a is the acceleration. In case of rotational motion, the equivalent of S, which is the distance, is theta. When theta will be in radians. Okay, omega is the angular velocity. Omega 0 is the initial angular velocity. T is the time. T is common for both. Plus half into alpha t square. Alpha is the angular acceleration. Just like the angular speed, we have the angular acceleration t square. In case of linear motion, we had v square is equal to u square plus 2as. In case of rotational motion, we have omega square. So omega is rotational velocity. Omega 0 is initial velocity, initial angular velocity, plus 2 into alpha. Alpha is the angular acceleration, and theta is the angular distance, which is theta here. Similarly, for v is equal to u plus at, omega is equal to omega 0 plus alpha t. Also, we need to know there is a term called frequency. So frequency basically tells us that how many revolutions it is completing in unit time. That unit time could be in unit minute, it could be in seconds, it could be in hours. Okay. So frequency is generally, as I said, frequency is generally revolutions per second, or it could be per minute, or it could be per hour. So basically it's a number of revolutions or rotations per unit time. The time period time period is denoted by T, and this denotes that how much time it is taking to complete one full. For example, if a body is rotating in a circular motion like this, how much time is it taking to do one complete rotation? So that is time period. Okay, and time period is equal to 1 by f. The relation between angular speed and time period is omega is equal to 2 pi by t. Okay, so this is the relation between omega and t. The relation tau is the torque here. Tau is the torque. Torque is equal to r is a positional vector, and f is the force being applied. Okay. So that was the formula for applying the torque. Okay. So now let's get into more detail on torque. So before we go there on this, so now let's explain how torque works, right? So imagine that we have a rod like this, right, which is hinged around here. Okay, we hinge around here, and if we apply a force from here, and imagine the length of this rod is L, so this will basically make it a rotational movement. Because it is hinged around here, it cannot move straight, so it has to rotate around here. Okay, and as we saw our formula in the previous section, the torque is equal to the radius into F. So in this case, the torque in this case will be, so torque will be nothing but torque will be L into L cross F. Okay, so this will be the torque here. Okay, and this will make the rod rotate around this hinge. Now, so imagine that if we let's now go back to this sketch we have drawn here. Uh, so here, so this was a very simple case of two dimension, right? Imagine there is three dimension space. We are trying to talk about how torque works. So imagine that this is a point here. The point is denoted by 4i plus 2j plus 7k, and we have to find that what will be the torque if the force is a certain force is applied around this, and we need to find that what the torque about the origin which is 0 0 0, right? And what is the magnitude of the force is being applied? It's 3i plus 3j minus 4k, right? So in this case we need to get the positional vector here, which is this. Okay, we need to get the positional vector, and which is we saw in our previous slide, right? So this was the positional vector r, this is a positional vector r, and this is the force applied here. Okay, so in this case also we need to get the positional vector here, which is 4i plus 2j plus 7k, and this multiply this by, or the cross multiplication with the 4, which is 3i plus 3j plus 4k. So now let's see that how will torque be computed now, right? So torque will be computed. So torque, as we said, is equal to R cross the force. Okay. Now, so what we're talking of here? So I, J, K. Okay, these are three vectors, right? So R, what it is? So this is R, which is a positional vector, 4i plus 2j plus 7k. Okay, 4i plus 2j plus 7k. Okay, and what is F here? F is 3i plus 3j minus 4k. 3i plus 3j minus 4k. Okay, so we need to compute this. Okay. Need to just clear this place. Yeah, so this is equal to, if I take I, so we just need to take this here, and 2 into minus 4 is minus 8, minus 3 into 7 is minus 21. So minus 8 minus 21 becomes minus 29. Okay, then we have to take the j part, but j part we need to take minus j. Okay, we need to do the same thing. 4 into minus 4 is minus 16. Minus 16 and 3 into 7 is 21. So minus 16 minus 21 is minus 37. Okay, and k we have to take this one. So now we have to multiply this by this. 4 into 3 is 12. Minus 3 into 2 is 6. So 12 minus 6, which is 6. 6. So how much this comes to? This is equal to minus 29i plus 37j plus 37j plus 6k. Okay. So this will be the magnitude of the torque. Okay. So this is the way torque is computed. Now, just to give an example here, so if this is a rod here, and this is the radius here, okay, the radius here, and the force is applied in this fashion, okay, which is tangent to the circle or tangent to this disc. Then, so this is the direction of the radius. This direction of the force. So torque will happen, the torque will be in this direction, right? So as you saw, torque is R into F, right? Torque is R into F. So since it's a cross product, you can understand that this will be in a direction, the direction of torque will be in a direction perpendicular to both the positional vector and the force. So force in this case, as per this drawing, right? The force is in this direction. okay, the radius is in this direction, so the torque has to be in this direction, right? So if what I want to say is that if the this is x direction is, for example, the if this x direction, if this is y direction, then this is z direction, okay, right? Okay, so the direction of torque will be perpendicular to both force as well as the positional vector. So this is how you compute the torque here, and this is how you find the direction of torque, which is nothing but the right hand thumb rule. Okay, now these are some of the formula which you need to know. What is cross product? We have seen earlier in vectors. A cross B, AB sine theta. What is dot product? A dot B is A B cos theta, means the magnitude of A into magnitude of B cos theta. How do you find V? Velocity is equal to angular velocity cross of R. Okay. Similarly, A, which is the linear acceleration, is equal to angular acceleration cross R. So these are the concepts on torque which you need to know when we go to the next section. So now we can come at more another important concept, which is about center of mass and center of gravity. This will be very important in this chapter. So let's understand what are these two things. So center of mass, as it suggests, this talks about the mass, right? This talks about the mass m. Okay. Center of gravity, as the name suggests, this talks about the gravity, or this talks about the weight. Okay. So center of mass, this focuses on mass. This does not depend on g, which is a gravitational acceleration. So gravitational field does not have any impact on center of mass. So whether it is non-uniform gravity or uniform gravity, doesn't matter, COM, it will not impact this, right? The point in object, where this is a point in object where the entire mass is evenly spread. So what do you mean by this? So imagine if you have an object like this, right? If you have an object like this, and imagine this is the center of mass, okay? So it means that all the masses which are there, right, this will be evenly spread around this point. If this is a COM, this has to be evenly spread. Now it could be at the same point, it could be at one of the edges also, depending on the magnitude of the masses on this body, right? Okay, so for example, if you look at this rod itself, right? So imagine that there is a m1 here, there is a mass 1, mass 2, mass 3, and mass 4. Okay, so imagine if mass 2, mass 3, and mass 4 are very heavy, then what will happen? The center of mass will actually shift somewhere on the right side. It will not be in the center. But if imagine if all the four are the same, m1, m2, m3, m4, then the center of mass might happen somewhere in the center. Okay, right? So this is a point in an object where the entire mass is evenly spread. So this is the point where the entire mass will be concentrated, right? This is the point where distribution of mass is even in all directions. Now it may lie inside the body, for example, for solid non-hollow bodies, and it may lie outside the body. So let's take an example, right? So we know this, imagine that this is a solid cylinder. This is solid cylinder, right? So since it's entirely solid, typically the center of mass will be on somewhere within the body itself. But if the same thing, say for example, if you have a hollow drum, right? If you have a hollow drum, then what will happen is that the center of mass will be somewhere in the middle of this drum, right? Somewhere in the middle of drum, but it will not be on the surface of the drum, but in the center, right? So if you have an axis like this, for example, going through the center of the drum, somewhere here, okay? Imagine if it is a symmetrical drum, it will not be on the body of the drum, okay? Now, so that is about the center of mass. So center of gravity, it focuses on weight, as the name says, it focuses on weight, which is mg. This is a point where the whole weight of an object is acting. The weight of the body is equally spread in all directions from the CG. So this looks very similar to the definition we had around this center of mass. The only difference being that we are talking of mass here and we are talking of the weight here, which is mg. Okay. Now, will it be as we said here, that G does not influence center of mass, but how does G influence the CG, right? So let's take an example. So imagine that if we have a very long object, right? For small object, the CG and the COM will be at the same point normally. But if I imagine that if we have a very big object, right? Imagine that this is the moon and this is the sun. Sorry, this is the earth. Okay, right. Imagine that we have very big body here, correct? So so imagine very big body like this, right, which is almost reaching the surface of the moon on one side and the surface of Earth on the other side. Now, you must be knowing that the gravitational force on Earth is much more than that of gravitational force on the moon. So, if so, for example, imagine if these are the masses on this particular object, okay, which are closer to the moon, so they'll be more influenced by the moon compared to the earth, right? But if and these points on the same object will be more influenced by the earth compared to that of moon. So now, where will the CG be in this case? So center of mass will not be changed. If this is symmetrical object, for example, a uniform rod, I'm just giving a hypothetical example. So center of mass be somewhere in the middle, right? So center of mass might be somewhere in the middle. But then where will the CG be? Because the gravitational pull will be more towards the earth, that is more towards on the right side, okay, compared to the left side. And what will happen is that the CG will be pulled more towards the right. So for example, CG might be located somewhere here, okay, somewhere here should I say, okay. So this might be the CG, okay. So this is the difference between the CG and the COM. Now, how do you compute them? So let's try to compute center of mass and center of gravity. So imagine that we have a rod here, right, which is shown here. We have a rod here. So imagine that this is center of mass, okay, this is center of mass, okay. So center of mass is, if this is center of mass, right, so imagine it goes to here, okay, center of mass, okay. So what is the total mass? We'll first need to compute the total mass, right? So total mass is equal to m1 plus m2 plus m3 plus m4. So this is the total mass of the body, okay. Now what will be the center of mass? How do you compute center of mass? This is equal to, if you take this as a reference point, so it will be x1 into m1. So x1 will be 0 here, right, because this is a reference point itself. So from x1 to 0, because x1 start from 0, it will be 0, but it will be complete like the x1 into m1 plus x2 into m2 plus x3 into m3 plus x4 m4 divided by the total mass, right? Total mass, which is nothing but sigma m, okay. So this is the way we compute the center of mass, okay, the compute center of mass. Now what about the center of gravity? How do you compute that? So let's try to clear this up a little. Okay. So now imagine that this is the CG, right? This is the CG point. Okay, this is CG here. So what will be CG? In case of CG, as we discussed, we talk about the weight, right? So I'll talk of weight 1, weight 2, weight 3, weight 4. So these are the weights of these 4 points which I have highlighted in red color here, okay? So here also, how do you calculate the CG here? So what is the total weight here? First, we need to find the total weight, which is equal to W1 plus W2 plus W3 plus W4. Okay. So what will be the CG in this case? So CG is equal to, very similar to what we had here also, right? X1 into W1 plus X2 into W2 plus X3 into W3 plus X4 into W4, okay, divided by the total weight which is sigma w. This sigma w is nothing but w1 plus w2, this thing, right? So this is the way we calculate here. And as we said here, because x, this is a reference point at the point w, this is w1 is a reference point here. So x1 will be 0 here, and this, in this case also x1 will be 0. So friends, having knowing these concepts now I think we can jump into the problems. Okay, let's go to the first problem now. Question 1. Two masses, each of 10 kg and 20 kg respectively, are attached to the two ends of a rigid rod of length 2 meter. Okay, so what is the length from here to here? This is 2 meters. Okay, this is 2 meters here. Okay, so imagine that this is x. If this is x, then what will this be? This is 2 minus x. Okay, so apply the formula as we discussed in our concepts, right? Apply concepts, then what happens is that, so imagine if the center of mass is at x, then x into the sum of the weights, right, 30, is equal to m1 x1 plus m2 x2, right? So m1 x1, what is the x1 here? It will be 0 because we are the point of reference for me is this place, right? So this will be 10 into 0 plus 20 into this distance, right? The distance of 20 from the reference point. This is a reference point for me. So that will be 20 into 2. So the right hand side it becomes just 40. Okay. So x is equal to 40 by 30 equal to 4 by 3 meters. So what does it mean? This is a normal reaction here. It is acting at a distance of 4 by 3. So that will become the center of mass of this system. Okay. Let's move on to the next problem now. A and B of mass 40 kg and 60 kg respectively are at the opposite ends of a boat. Okay, so imagine that there is a boat here. Okay, imagine that boat is sailing in water. Okay, imagine there is a boat sailing in water. The length of the boat is given to me. It weighs 150 kg. Okay, so what is given to me? Length is given, weight is given to me. Okay, and there are two people, A and B, which have their individual weights 40 kgs and 60 kgs. Okay, so A walks up to B and remains with B. The boat is in still water, right? So the boat is given to in still water. It is asking by how much distance has the center of mass of the system moved. So in this case, there is actually there will be no change here. There will be no change in center of mass because there is no external force applied. Okay, since there is no external force, so it means no change in center of mass. Okay, so no change in this, right? Let's go to the next problem now. Two particles which are initially at rest move toward each other with speed of 2v and 3v. Okay, so in this case also, if you look at the entire system, there's no external force applied here. It's just that they're just moving towards each other. Okay, so the center of mass will remain at the same point. Okay, there is no external force here. There is no external force, so it means that no change in location of center of mass, right? Okay, so if there is no change in location, means that the location, this is not changing, so the speed What is speed? Speed is the rate at which it is changing, the center of mass is changing, right? Speed is equal to 0. Okay, if you look at the answer, we have one answer with value equal to 0. This will be the answer. Okay. Then the next problem, okay. Two bodies of mass 2 and 5 kg have the position vectors 2i plus 4j minus k and minus 2. So, right, what is the position vector of center of mass? So if you remember in the concepts, we discussed that. In the concepts, what did we discuss here? That we just need to apply this formula for all the three coordinates, right? So one for x, other for y, and the same for z. Okay, we need to apply the same formula there. Okay, so we come back to this now. So we can just say that center of mass of this is equal to 2i plus 4j plus k to 2, right? 2 plus 5, right? 5 into minus 2i minus 3j minus k, okay? And this we need to divide by the total mass is 7, okay? So this is what 2 into 2 is 4i, 4j plus 2 is 8j, and k into 2 is 2k. Okay, plus 5. 5 into minus 10i is equal to minus 10i. Okay. 5 into minus 3j becomes minus 15j. 5 into minus k becomes minus 5k. Okay, so we now, and this is entire thing divided by 7. So I'll write 1 by 7 outside this. Okay, so what do you get here? 4i minus 6i is equal to minus 4i minus 10i is equal to minus 6i. So 1 by 7 of minus 6i. 8j minus 15j is minus 7j. Okay, plus 2k minus 5k, it becomes minus 3k. Okay, so the answer will be minus 6i minus 7j minus 3k divided by 7. So I think this will be the answer. This third option will be the answer here. Okay, let's go to the next question now. A particle starts from rest. It moves in a circle of radius r. It attains a velocity v in the kth round. What is the angular acceleration? Okay. So in this case, we just need to apply the same formula what we learned earlier. So we need to find the angular acceleration, right? So let's first go this in linear. What do we know here? V square is equal to u square plus as. Okay. Just change the color. Yeah, v square is equal to u square plus 2as. Now, what is the distance in k rounds, right? It is said now that it is undergoing k rounds, right? Is equal to circumference, right? So what is circumference? We know a circle is 2 pi r, okay, into k. So 2 pi k r, okay? This is a total distance being traversed, okay? So why are you doing this? Because we are applying this formula. So v square is equal to u square plus 2 into a into 2 pi k r. Yeah, it means, so now since it is given in question that the particle starts from rest, so it means this is equal to 0. So this becomes v square is equal to 4a k 4a k pi r. Okay, so this is the velocity square here, right? So now we know that v square is equal to u square plus 2s. Okay, so it means from this particular thing we know that a is equal to v square divided by a is equal to v square divided by 4 pi k r. Okay, now we had discussed earlier that what is a is nothing but equal to r alpha, means r alpha is equal to v square upon 4 pi k r, right? We're just using this formula here, right? Just copy pasting this formula. Okay, so now, so what is alpha then? Alpha is equal to v square upon 4, r will come this way, right? So we have 4 pi k r square. This will be the formula, right? So v square by 4k p, I think this is the answer. The first one is the answer, okay? First one is the answer here. Okay? Let's go to the next question now. Okay, the linear density of a rod of length 4 is proportional to x square. Okay, so we know that mass is equal to density, right? Let me write full thing down, density into the length. Okay, right? Now what is COM or CG? It's equal to summation of, we are done earlier, right? x1 m1 plus m2, x2 m2 and so on, x into mass, okay, divided by the mass, total mass. Okay, so now mass of dx is given that it is proportional to x square, right? It is proportional to x square, so I can write that mass is equal to kx square. Okay, I can write this. So what is the what is the mass of dx? Mass of dx is equal to k into x square dx. Okay, so what is CG here? CG is equal to center of gravity is equal to 0 to 5 x to k into x square dx. Okay, divided by 0 to 5, okay, k x square dx. Okay, where is kx square dx coming from? This is coming from here. Okay, right? So it means the CG is equal to, if we take this one, right? So if we just do like this becomes x into x is x cube, right? So this is k. I can take this outside because this is a constant, k x cube dx 5 0. Okay, similarly for this one, this will be 0 5 k x square k, I'm taking k outside, x square x. Okay, so what is this one here? K x 4 by 4 5 0. Okay, and this one becomes x cube, k x cube by 3 5 0. Okay. So what does it become now? K. So x to the power 4 is nothing but 5 to the power 4, right? And 5 to the power 4, what is that? 5 5 25, 5 is 125 and 625. Okay. This is equal to 625 by 4 power 5. Okay. Divided by x cube k to x cube by 3. X cube by 3 is nothing but 8 cube by, sorry, I made a mistake here. Okay, this 8 cube by 8 by 8 cube, this is 8 cube by 3 is equal to, so I can cut the k's all over, so it becomes 625 by 4 divided by 625 by 4 divided by, oh sorry, so this should have been 5, right? Sorry, this should have been 5. Sorry for that. So this should have been 5 cube. Okay, this should have been 5 cube here. Okay, so this is 5 cube. So this should have been 125 by 3. 5 cube, this should be 5 here, okay? This is 5. So equal to 15 by 4. This is equal to 3.75. Okay, this will be meter here. Okay, the answer in this case is C here. Okay, fine. So friends, we have completed the first 6 questions in this exercise. In the next video, we'll complete the rest of the problems. So friends, I hope you are enjoying these videos. If you have any suggestions, then you can please drop in the comments section. Okay, and if you are liking it, then I'll request you to like the videos and subscribe the videos, subscribe to the channel. It will help us, or it will motivate us to create more educational content for you and help in making you more more completely prepared for your exam. So we'll meet you in the next video. Thank you. Have a nice day.